Hello class 9. So it's been quite a while since I posted a video. So this is the second half of your atmosphere and layers chapter. So in the first half you saw atmosphere along with its layers and global warming, greenhouse effect and all kinds of air pollution related stuff. The second half is insolation, terrestrial radiation and temperature related topics which we'll be focusing today. So this word insolation can be divided into three: in, solar and shun. So the reason why it's split into three is to easily understand what it means, and you will be told why it's split into three in the coming slides. This is your syllabus. I hope you have one copy of it. If you don't have a copy of it, please send a message to the school WhatsApp so that I'll get a notification and I'll attach a PDF along with your next homework. So it includes the first chapter or the first heading, the second heading, which has all subdivisions, and all these subdivisions are separate chapters in your textbook. So all the chapters we haven't completed. And in the topic number 4, the subtopic number 1, composition and structure of atmosphere, that is what we have completed earlier. And the subtopic number 2, insolation, meaning of insolation, terrestrial radiation, factors affecting temperature, latitude, altitude, distance from the sea, slope of the land, winds and ocean currents is what we'll be focusing today. So please remember, this is very important. You have to know your syllabus, because 9th standard and 10th standard the syllabus is quite vast. So it doesn't matter if you are well versed with your textbook. If you know your syllabus, you can gather a lot of information more than your textbook. Because for your board exams, it is not from this textbook which you follow that questions are going to be made from. Till your 8th standard, all your exams are like that, but from your 9th, it's not going to be like that. So please remember, your syllabus is very important. Gathering information beyond the syllabus is very good. Appreciate that. But for your exam, stick to the syllabus and try to improve your understanding of each and every topic based on what is given. And then you can gather more information. It's very good. And topic number 5, or heading number 5, pollution, has 4 subtopics and all those 4 are covered. I haven't made a PowerPoint video related to that, but still I guess we had gone through it through the homework pattern. If any of you have doubts related to it, you can contact me in the next Zoom class. Moving into this chapter. In this chapter, just like how I mentioned earlier, we'll be learning about the meaning of insolation and terrestrial radiation. We'll also be focusing on the factors that are affecting temperature. And these are the 6 factors that will mainly affect temperature. There are other factors also. These are the 6 that affect temperature. Okay, now there's going to be a video, and since we're going to learn about temperature, let's get an overview or an understanding of where this temperature comes from. We all know that the temperature comes from sun, and sun is the main source of heat and light. So let's get an understanding of what is sun. We just know that sun gives heat and light, and it's far away, it's so big, and it's so powerful, you can't reach the sun. These are some information we have known about the sun. But this video will give you a deeper understanding of what is the sun, and how much information you can gather about it, or you can get to know about it, is much more vast in this video.
While billions of stars are scattered throughout the universe, the one at the center of our solar system plays a special role for us here on Earth. Our sun formed about 4.5 billion years ago in the Milky Way galaxy's Orion Spur. It was born when a cloud of dust and gas, known as a solar nebula, collapsed. And in the middle of this formation, matter condensed into a burning ball of gas that became our sun. The sun's fiery nature, along with a tremendous gravitational pull and an extensive magnetic field, helped it to become the heart of our solar system. The sun can be divided into 6 layers or regions: the corona, the chromosphere, the photosphere, the convective and radiative zones, and the core. In terms of atom count, the Sun is about 91% hydrogen, the Sun's fuel, 8.9% helium, and 0.1% heavier elements, such as carbon and nitrogen. Due to the Sun's extreme temperatures, these elements stay in a gas-like phase called plasma. In the core, temperatures reaching at least 27 million degrees Fahrenheit, combined with the Sun's powerful gravity, fuse together hydrogen molecules to create helium. Called thermonuclear fusion, this releases an enormous amount of energy in the form of radiation, electricity, solar wind, and, as we experience on Earth, life-giving heat and light. Such volatility is contained thanks to the Sun's tremendous gravity. It's strong enough to hold the solar system intact and is primarily due to the Sun's size and mass. Our Sun is the largest and most massive object in the solar system. It's more than 100 Earths wide and could theoretically fit all 8 planets inside nearly 600 times. It also contains approximately 99.8% of all the mass in the solar system. Because of this mass, the Sun has a great pull on the fabric of space, creating a gravitational force that causes nearby planetary bodies to be drawn toward it. This gravitational pull allows the Sun to hold together a system of 8 planets, potentially dozens of dwarf planets, at least 170 moons, and countless comets and asteroids. Without the Sun's gravity, these celestial bodies would drift off into deep space.
Okay, so that gave a deeper meaning and understanding of the Sun. We all knew that the Sun gives heat and light, but in this video we understood that because of the enormous amount of heat and thermonuclear fusion, hydrogen being converted to helium, there's electricity being produced, there's solar wind being produced, and there's so much energy being produced. So we understood that Sun is real. If Sun is really powerful, the rays or what it gives out is also going to be really powerful. Before moving into the topic, there are 3 basic terms which you need to know, which I probably believe that you would have heard quite a lot of times, and that will give you a better understanding of the chapter. So conduction, convection, and radiation are 3 basic terms you would have learned in your physics or chemistry or science in your lower classes. But let's brush up what it is again. Conduction is when energy is transferred by direct contact. So in a solid, when one molecule gets heat energy, without moving to another place, it heats up the molecule next to it. For example, a hot iron rod, it's kept on fire. One end is on the fire, the other end is not on the fire, but still if you keep it for a long time, if you touch the other end which is not on fire, you'll still feel so hot, because even though the molecules inside doesn't move, it transfers the heat from one to the other because of direct contact. That's conduction. Next, convection. Convection is energy being transferred because of motion or movement. There was no movement in conduction, there is movement in convection. So when you boil water, what happens? The warm water molecules from the bottom, because it's warm, it becomes lighter and it goes up. What's on top? Cold water molecules. And that, because it's heavier now, has to sink down. There's a cyclic process where what is warm is going up, what is cold is coming down. When you boil water, you can see small air bubbles. That's the water molecules becoming warmer and turning into water vapor, and because it becomes lighter, it is rising up. So the colder air and water molecules on the top goes down. So this cyclic process actually warms the whole liquid, and that process is called convection. What about this third one, radiation? In conduction there was contact, no movement. In convection also there was contact but with movement. In radiation, heat is being transferred in the form of waves. You have a fire and you keep your hand far away, or you even have a pan, and without touching the pan, if it's on fire for a long time, if you keep your hand above the pan without touching it, you can feel particular amount of heat. That is radiation, and that is exactly what you get from the sun. Sun is a huge mass which has so much of heat, but we don't touch the sun for us to feel heat. There is no cyclic process for us to touch and feel the heat. What is cold within the surface doesn't go to the sun, or what is warm doesn't come to the earth. There is no cyclic process that takes place. So we know that what heat we get from the sun is not conduction, is not convection, but it is radiation. It's exactly how we see in the picture. A hand which is close to a fire, it's not touching the fire. There's no cyclic movement taking place from warm to cold and from cold to warm, but still you feel heat, and that is radiation. So we'll be learning about how radiation happens from the sun to the earth and from the earth to the sun. So now you understood the three basic terms, you'll be able to easily understand the chapter. So I had split the word insolation, and I told you that you will understand what is the meaning of insolation in the few next slides, and this is the meaning. In represents incoming, solar represents solar, which means sun, and shun, Tion, is a representation of radiation. So now every time you hear the word radiation in this video, think about that hand which was near the fire. It was not touching it, it didn't have a cyclic convectional rotation of molecules from hot to cold and cold to hot, but it is still getting heat. So every time you listen to the word radiation, remember that picture. Incoming solar radiation, short form is insolation. So insolation is solar radiation or sun rays and light and heat from the sun, which is incoming or coming towards the earth. What about the next one? Terrestrial radiation. We have heard the word terrestrial, terrestrial animals, animals living on earth. Extraterrestrial beings, living beings or any kind of living animal or a living species which is not from earth, which is still being debated whether extraterrestrial beings like aliens are present. So extraterrestrial means outside earth, so terrestrial means earth. So the radiation which goes out from earth is terrestrial radiation. So here is a picture which shows both insolation, the red lines or the red arrows, and terrestrial radiation, which is the ones which are going out. Incoming solar radiation are the incoming solar energy that hits the surface from the sun. What about terrestrial radiation? Terrestrial means earth, while terrestrial radiation is the heat which was absorbed by the earth's surface. Obviously, when the insolation is happening, the heat or the light which will hit the earth, some will get reflected but some will get absorbed, right? So what was absorbed by the earth's surface is radiated back after a long time, most probably at night. During day we have sun, so we absorb, or the earth absorbs during day and it gives back at night. Solar energy travels in the form of electromagnetic waves. We know, or you would have learned about the electromagnetic spectrum. There are waves. In the middle you have a visible portion of light, and on the left you have long waves, on the right you have short waves. Short waves include gamma rays, X-rays, and all the waves which have a shorter wavelength which travel very fast. But long waves like ultraviolet radiations or infrared radiations travel really long, or it has a longer wavelength. So incoming solar radiations are traveling in the form of short waves or having lesser wavelength, while outgoing terrestrial radiation takes place in the form of long waves or higher wavelength. In your textbook you can see a picture of long waves and short waves along with the visible spectrum clearly given when this chapter is explained. There will be a picture of the electromagnetic spectrum. So when you are listening to this, if you open that picture and keep it right in front of you, you will be able to understand it in a much more easier way. If the sky is clear, more energy reaches the surface, but if there is clouds, it is less. Obviously, clouds will absorb most of the sunlight and heat, so there will be less amount of heat and light which is reaching the surface. But if there is no clouds and there's a clear sky, there will be more amount of heat and light reaching the earth's surface. Most of the terrestrial radiation is absorbed by the gases and clouds, while the rest is directly emitted into space. So we know terrestrial radiation is the heat and light, or heat mainly, given out by the Earth's surface after it was absorbed during the day. When it is giving out, it is again mostly absorbed by the clouds, but there will be some which are not absorbed by the clouds and are directly emitted into the surface. If you look at the picture, there are three blue lines. The line on the left is the waves or the heat waves which are directly emitted into space. There is no hindrance of clouds. But there are two smaller lines on the right which are going from the clouds, which means it hits the clouds, it gets absorbed, and later from the clouds it goes back quite some time. Okay, so now there is a relationship between what is coming in and what is going out. There is a connection between insolation and terrestrial radiation. So what is the ratio? If there is 100% of light coming in, is there 100% of light and heat going out? If there is an equal ratio or a balance, then there we can call it heat budget. If there is no balance of the amount of heat coming in and going out, then there's an imbalance on the Earth's system and life on Earth would not exist as how it is existing now. The balance or equilibrium maintained between the units of energy of insolation and terrestrial radiation is called heat budget. So insolation we'll call it 100 units because it is coming from the sun, it is coming from the source. We'll give 100 units to insolation. So among the 100 units, you can see 35 units are reflected by the clouds and the surface. 14 units are absorbed by the atmosphere. So 35 and 14, if you add together, you have 49 units. Okay. None of these 49 units are absorbed or has reached the Earth's surface. 14 has been taken away by the atmosphere, 35 has hit the clouds and reflected, and some have hit the surface and also reflected. But nothing has been absorbed by the Earth's surface, which means we human beings or life living on Earth haven't received any of these 100 units so far. So you take away the 49, there's remaining 51. Those 51 units are the amount of sunlight which reaches the Earth's surface or gets absorbed by the Earth's surface. But on the other hand, terrestrial radiation doesn't have 100 units because we know that terrestrial radiation is the amount of heat and light, mostly heat, which is given back by the Earth. We can give back only what we got, but how much did we get or how much did the Earth get? 51. So the total amount of units which terrestrial radiation can give back itself is not 100 but 51. Among the 51, 34 units are radiated from the surface, but it gets absorbed by the atmosphere and the clouds. But 17 units which are radiated from the surface is also absorbed by the clouds and the atmosphere, but later it is emitted from the clouds and the atmosphere. I'll explain it again. Among the 51 units, all the 51 units are going out of the Earth's surface because only if it goes out there will be a balance. But in the 51 units which goes out, 34 is absorbed by the clouds and the atmosphere and it stays inside. The remaining 17 which goes is also absorbed by the atmosphere and the clouds, but that doesn't stay within it. It goes out of the clouds and the atmosphere after some time. So Earth's surface got 51 units. It gave back 51, but only 17 reached the outer space. And 34 is still within the atmosphere. Okay. So if we conclude, we can see that insolation 100 units of energy is equally being split out of some being reflected, some being absorbed by the atmosphere and some reaching the Earth's surface and being absorbed. Terrestrial radiation, if we conclude, the 51 which was received, 34 is going to the atmosphere and it stays in the atmosphere, 17 goes to the atmosphere and then later from the atmosphere and clouds, it goes to the outer space. Since the atmosphere is heated more by terrestrial radiation than insolation, temperature at low altitudes decreases with height. So always in the last portion or last part of this chapter we learned that in the troposphere on the lowest surface, when we go higher and higher and higher with altitude, temperature decreases. On the earth's surface, when you are living in a plain or in a city which is near the sea level, you have high temperature. When you go to a mountain top or a hill station at higher altitude, it is lower temperature. The reason is this: the atmosphere is more heated by the Earth's surface, by terrestrial radiation. See how much units the Earth is giving to the atmosphere. 34 units is absorbed by the atmosphere from the Earth. But only 14 units is absorbed by the atmosphere from the Sun. So it sounds really funny, but it is true that the atmosphere becomes more warmer not by the Sun but by Earth. And that is the main reason why the temperature is more warmer closer to the surface than it is far away from the surface. So to put all this together in simpler words, when there is a balance between insolation and terrestrial radiation, heat budget is achieved. So because of heat from the sun towards the earth's surface, we understand that different parts of the earth doesn't receive same amount of heat. You would have learned about this in your previous classes, but we'll just go through it once more. So we can divide the earth into three zones: tropical or torrid zone from 0 degree latitude or equator to 23 degree north and south. There you get vertical rays of the sun, you have maximum sunlight, heat and rainfall in these regions is very high, so you will have dense rainforest or high amount of vegetation can be found. Temperate zone, which lies between 23.5 degree north to 66.5 degree north and 23.5 degree south to 66.5 degree south, because it is not exactly in line with the sun, slightly inclined rays fall here. So average light, heat, low humidity, deserts and grasslands, dry grasslands are seen here. What about the frigid zone or the polar zone? 66.5 to 90 degree north and 66.5 to 90 degree south. Highly oblique rays or slanting rays fall here. Absence of sunlight for 3 to 4 months. There will be 3 to 4 months when the North Pole is facing the sun, the South Pole will not face the sun, and the same happens oppositely. Very less sunlight, heat, dry climate prevails here. More sun, more snowfall and less rain. Permafrost regions are seen here. The meaning of permafrost is permanently frozen regions are seen. Okay, before we move into the next part, I would like to ask a few questions. These are questions which you would have heard or you wouldn't have heard, but these are questions about places in our country. And why is some place warmer than the other place? Why does some places receive more rain and some places receive less rain? So the main purpose of learning this topic of insolation, terrestrial radiation, and difference in temperature from place to place is for you to reason. If is for you to start thinking, okay, this is the reason why this place is warmer, this is the reason why here you have more humidity, this is the reason why this place gets more rain. If you are able to reason and understand why a particular place has a particular amount of temperature or has a particular kind of climate, then that is the biggest achievement you get from this chapter. Learning whatever I teach or learning much more information from outside and doing your homework and getting marks, that is one side, but I want you to reason and start to think. So I'll give you some questions, and while we go through the next part of this chapter, the factors that affect temperature, I want you to remind yourself and keep asking yourself, what is the answer for those questions? You will get the answers for all those questions by the time we finish the second half. So we'll quickly run through the questions. Question number one: coastal cities in India don't have frozen water bodies like coastal places in Europe. So if you take a coastal place in Europe like Finland or Iceland, all along the coast you will have frozen water bodies. The water bodies will be frozen along the coast. But in India there is no frozen water bodies along the coast. Number two, India's capital Delhi has a higher average temperature than Russia's capital Moscow. Both are in Asia, but still India's capital Delhi has a higher average temperature than Russia's capital Moscow. The reason, what is the reason? Question number three, Himalayan slope. So we know that the Himalayas is right cutting across India, Nepal and China. So there is one side which is facing Nepal and China, another side which is facing southwards towards India. So the Himalayan slope which is facing India has lesser amount of snow than the slope which is facing the other side or facing the northern side, which is China and Nepal. What is the reason? Uttarakhand has colder winters than Karnataka. What is the reason? Dehradun is more hot and dry, while Tamil Nadu in the south is more humid. What might be the reason? Kerala gets hit by monsoons or monsoon rains during June, but Dehradun is hot and dry during the same month. Now we'll be moving into the topic which I've told you. This is a very important topic which we is related to the questions I've given, and it's factors affecting temperature on Earth. So factors, this word you will be hearing again and again in your higher classes. What are the factors that affect temperature, affect rainfall, affect climate, affect humidity, affect pressure? And you will hear the word factors not just in geography but in physics, in chemistry, and even in biology, or even in other sciences or other subjects. So factors is nothing but the reason, or what are the reasons that changes temperature, either increases it or decreases it. So if you start thinking, or in other words reasoning, you will obviously get the answer. And we'll be discussing just a few factors or a few reasons why temperature on the earth is not same everywhere but different. Number one, latitude. Regions that are closer to the equator or in lower latitudes experience more temperature than regions far away from the equator or in high latitudes. This is a statement. What is the reason? The reason is that the sun rays hit equatorial regions, as you see in the picture, right at the center, vertical rays, vertically at 90 degrees. So these rays hit only a small portion of the Earth's surface, hence a small portion gets extensively heated up. See area Y in the figure. So if you see area Y in lower latitudes, because the sun rays is almost vertical, only a small area gets heated up. So the same amount of sun rays which is falling at a large area at higher latitudes is falling at a small area in lower latitudes, and it gets heated up very fast. But the sun rays that hit higher latitudes fall at an angle. So when it falls at an angle, just like area X, it falls at a larger area and it only gets slowly heated up. So this is reason number one, or factor number one, which affects the temperature. What about factor number two? Altitude, or height from the sea level. Higher the altitude, lower the temperature. So this doesn't apply to all the atmospheric layers, only the lower atmospheric layer or the surface of the earth. Higher the altitude, lower the temperature. Reason? Due to higher number of air molecules present near the surface, the density of air is always high and lower altitudes. Since there are more air molecules, all the air molecules will absorb heat and naturally it will be higher at the surface. Why does lot of air molecules, why they are present at the surface or at lower latitudes? It's mainly because impurities, dust and pollution is very high at the surface and it's not much high at higher altitudes or at mountain tops. So because of high impurities, dust and pollution, there are a lot of air molecules, and when there are a lot of air molecules, there is higher density and all these air molecules absorb heat, so there is higher temperature near the surface. There is an increase of 1 degree centigrade for every 165 meters increase in altitude. Sorry, there is a decrease of 1 degree centigrade for every 165 meters in increase in altitude. So when you go 165 meters higher, you actually go 1 degree centigrade lower. So here is a picture which is shown in Fahrenheit and feet, not in meters and centigrade. And here it shows slightly something different because it is the same mountain peak which is at 1000 feet from the sea level, but the temperature which is decreasing is totally different on a cloudy day compared to a sunny day. What is the reason? In a cloudy day or a snowy day or a rainy day, or in other words in a cloudy, snowy or rainy region, air is filled with a lot of water vapor, and the water vapor will naturally decrease the temperature because water absorbs more heat and it doesn't allow the heat or allow the air molecules to get warmed up because there's a lot of water vapor in them. So increase or decrease in temperature when the altitude is increasing is very low. Compared to warm places when there is no clouds, no humidity, no rain, or in any region where it is totally sunny, there is zero water vapor, the air is very dry, so it can easily be heated up and temperature easily reduces when you go above. But always remember, just like how we learned in the previous video session, this is applicable only to the troposphere. In the stratosphere, temperature increases with altitude. In mesosphere, again, it decreases with altitude. In thermosphere, again, it increases with altitude. So all these conditions are applicable only to the troposphere and not to. What about the next factor? Distance from the sea. Places which are near the coast have a milder climate, unlike regions far away from the coast or from oceans that get or far away from regions far away from oceans become more hot. So here is a picture of Europe. What you see in the right, where it's written Shannon, is a small part in Great Britain or UK. And then you can see places like Berlin, which is in Germany, Warsaw, which is in Poland. So all these European places you can see. Shannon is actually closer to the sea, while Berlin is a little more far away. Warsaw is much more far away. And you can see that the temperature is very different in the same month when you compare Shannon, Berlin and Warsaw. What is the reason? This is because the land gets heated up faster than the ocean. Okay, so Warsaw gets heated up faster than Shannon. In coastal areas, when the land gets heated up during the day, the ocean cools it down by sea breeze. This cannot happen in continental or inland areas. So when Shannon gets heated up, because it's closer to the sea, it can easily be cooled down. But Warsaw, when it gets heated up, it cannot be easily cooled down. So the temperature will automatically rise much more higher. See, here is a picture which shows a clear description of how the land gets heated up more and land gets cooled down more. But when it's near to the ocean, because of sea breeze and land breeze, when the land gets heated up, the ocean cools it down. When the land gets cooler, the ocean warms it up. Even a change in season doesn't have a big difference, temperature difference for coastal areas, but inland regions or continental regions have a huge difference. If you look at the same Shannon, Berlin, Warsaw picture, you can see that during the month of July, which is the hottest month for European countries, Shannon has 15 degrees centigrade, while in winters they have 6 degrees centigrade. But if you look at Warsaw, the temperature is much more higher because it's continental and it's far away from the ocean. The ocean cannot cool it down. The same way when it is colder, the ocean cannot warm it up, so it's much more colder. So it's not just it's becoming too hot, it's becoming too cold as well. So a change in season creates a big difference in temperature, whether it is rising or decreasing. Factor, slope of the land. In the northern hemisphere, the slopes facing the south is warmer than the slopes facing the north. The same way, in the southern hemisphere, the slopes facing the north is warmer than the slopes facing the south. I think it appears to you as a tongue twister, but don't worry, it's pretty simple. So we have two hemispheres, the northern hemisphere and the southern hemisphere, right? So in both hemispheres, will have mountain ranges, and we know that the sun rays fall maximum on the equator. So there's a word equator written on top and sun is right below it. So let's imagine the sun revolves the earth around the equator. And above the equator you have northern hemisphere, below the equator you have southern hemisphere. And on both hemispheres you will have mountain ranges. And mountain ranges will have slopes also. So any mountain range which has a slope facing southwards, which means it is facing towards the equator, or any mountain range in the southern hemisphere which has a slope facing towards the equator, which is facing northwards, will be more warmer than the other slopes. So that's the reason. Since the sun shines maximum along the equatorial regions, all the mountains and equators, all the mountains and hills on either sides will have warmer slope and a colder slope. Obviously, the warmer slope will be the one which faces the equator. Sometimes the slopes and higher reaches of mountains will be warmer than the low-lying valleys. How can that happen? Quite a few moments before we learned that when we go higher in altitude, the temperature decreases. But here it is written, sometimes the slopes are having higher temperature, slopes and higher reaches of mountains will be warmer than the low-lying valleys, which means when we go higher in the mountains, the temperature will be higher, and lower in the valleys, the temperature will be lesser. How can that happen? There is a reason behind it. So, in plain areas, we know that temperature is warm or hottest On the surface, when you go higher and higher and higher, it becomes cool, cooler, and much more cooler. So when there's a slight valley or depression, cold air, because it is heavy, it sinks down. When cold air sinks down, the warm air which is present in the valley needs to obviously rise up. So there is cool air at the bottom and warm air on the top. But after the layer of warm air, again there will be colder air. So here there is an opposite appearance of cold air at the bottom and warm air above it. So that is called temperature inversion. So temperature is actually inverted. Usually it is warm at the bottom and cold above. In some places or valleys, it is cold at the valleys and warm above on the top of the hill. Cool air from the peaks sinks to the low-lying valleys, and this sinking is called mountain breeze, from the mountain to the valley. And warm air from the valleys moves upward from the valley to the peaks, which is valley breeze. When this continuous, like sea breeze, land breeze, when this mountain breeze, valley breeze reaction or cycle happens, there is a temperature inversion that takes place. This leads to temperature inversion, causing warm air to stay over the peaks and cold air at the valleys. But it is only for a small layer, it is not for a large portion. That is why, but above the peaks at much more higher altitudes, again there will be a decrease in temperature. So you don't have to confuse anything. Slope of the land means the slopes on either hemispheres facing the equator will be warmer than the slopes which are not facing the equator. That is point number one. And next is, sometimes there is cold air sinking in the valleys and warm air rising to the peaks. Because of that, there is an inverted appearance of temperature where cold air is below and warm air on top, which is called temperature inversion. So these are the two you have to keep in mind. Point number 5. Winds. Winds also affect temperature significantly. Temperature of regions that receives constant wind varies significantly. So any region which has so much winds will not have the same temperature. The common thing that comes to our mind is land breeze and sea breeze. So the regions which are closer to the ocean, just like how distance from the sea is affecting or changing the temperature, the same way the winds which are blowing from the sea to the land or land to the sea is affecting the temperature of the area. Winds bring cold or heat depending upon where it comes from. If it comes from the ocean, it brings cold, or it comes from polar regions, it brings coldness. If it is coming from an equatorial region or from the land, it brings heat. Sea breeze cools down the land because it is originating from a water body, while land brings warms up the land because it starts from the land. Mountain ranges block the flow of the wind, also changes the temperature. Because in this picture you can see wind direction is in one side, the other side doesn't get any wind. So there is a huge difference in temperature when you compare the left side of the mountain to the right side, because one side gets wind and the other side doesn't get wind. So mountain ranges also block and change the temperature of the earth. Winds blowing from valleys to peaks and vice versa also plays a huge influence. Just like how we discussed in the previous slide, valley breeze and mountain breeze also influence temperature. Last point, and very important, permanent winds like westerlies, easterlies and trade winds. These are the permanent winds which always flow from one latitude to another on the surface of the earth. We will be learning about this in detail in the next chapter. So this also creates a huge influence. So you can see blue arrows from one latitude to the other latitude. So these winds always blow on the surface of the earth. So this also plays a huge. The last factor is ocean currents. Ocean currents are actually moving masses of water. So when a large volume of water moves from a colder region to a warmer region on the surface of the ocean, that is called ocean current. So it's like exchanging, taking, you have two buckets of water. One bucket is full of warm water, the other bucket is full of cold water. You take a small cup or a mug, scoop out one mug full of warm water and pour it into the cold water. Scoop up one mug of cold water from the bucket and pour it into the warm water. You are actually balancing both the temperatures. So when the ocean does the same process what I told you, that is called ocean currents. From colder regions, ocean will give some water to the warmer regions. From warmer regions, ocean will give some water to the colder regions. You can see red lines and blue lines. Red lines indicates warm ocean currents. The areas where ocean has warm water, it is giving it to the colder regions, or it is moving around from the warmer to the colder regions, while the opposite happens in the polar or regions far away from the equator where the water is cold. It is balancing by moving towards the equator. Ocean currents are moving mass of water along the surface of the ocean. Warm ocean currents stands for warm water from the lower latitudes to polar regions, while cold ocean currents stands for cold water from higher latitudes to the equatorial regions. So you can clearly understand what is written through the picture. As cold water prevails around higher latitudes, so you can see a lot of blue lines along higher latitudes, which means along 60° north, 60° south, 70°, 80°, 90° north and south, along where Arctic region and the Antarctic region is seen, you can see a lot of blue lines. So these blue lines indicate cold waters. So the cold water prevailing at higher latitudes or polar regions, the coast there will be colder. Warm water prevailing over lower latitudes, the coast there will be warmer. Ocean currents can also bring warmer climate to northern coasts if the coast receives warm ocean currents from lower latitudes. So just because cold water is surrounding or in and around the polar regions, it doesn't mean that it is always cold. Sometimes a warm ocean current can come from the equatorial region to the polar regions to balance the temperature. So that can reduce or increase the temperature of a polar region. The same way, if a cold ocean current is going from a cold region to a warmer region or warmer coast will become cooler. So here is a picture which clearly describes when there is a warm ocean current which is coming to a colder region, the iceberg or ice sheet starts to melt and the thinner regions of the ice sheet starts to collapse. So that causes melting and increase in sea level. So when there is a balance between warm ocean current and cold ocean current, the sea level won't rise and there will be a balance in the whole system and functioning of the earth. So you remember the questions which I asked before teaching the factors? Were you able to get any answers for the questions I asked you? Okay, if you try to get some answers, good. If you didn't try to get some answers, pause the video, go back, go through the factors and try to answer it rather than going front. Anyway, I'll be giving you the answers. If you have already found out the answers, you can check whether your answers were right. Number one, coastal cities in India have frozen water bodies unlike coastal places in Europe. What is the reason? The last point which we discussed. Warm ocean currents mostly flow near Indian coast because India is near to the equator and the central lower latitudes, unlike ocean currents which are cold which flow along the European coast. That is why India doesn't have frozen coasts or colder coasts unlike Europe. Question number two. India's capital Delhi has a higher average temperature than Russia's capital Moscow. What is the reason? Delhi lies at lower latitudes near to the equator unlike Moscow which lie at higher latitudes far away from the equator. Third point, Himalayan slope facing India has lesser snow than the slope facing China and Nepal. So when we learned about the slope, nature of slope, we learned that in the northern hemisphere, we know already also know that India is in the northern hemisphere. So in the northern hemisphere, the slope which is facing the south will get more sunlight. So the slope which is facing the south is the slope which is facing India. So when it gets more sunlight, it melts a lot of snow. So that is why India has a lesser amount of snow. But the slope which is facing northways is the slope which is facing China and Nepal. And that is why that portion gets lesser sunlight, so lesser melting and more amount of snow. Uttarakhand has colder winters than Karnataka. What is the reason? Because Uttarakhand is at a higher altitude and closer to a snowy mountain range. Karnataka also is at some regions in Karnataka is at a higher altitude but not as high as Uttarakhand, and no region in Karnataka has a snowy mountain range. So these are two factors which are important for Uttarakhand to have colder winters than Karnataka. Dehradun is hot and dry while Tamil Nadu is humid. What is the reason? Because Dehradun is more distant and far away from the ocean. So there is no water vapor. If there is no water vapor, there is no humidity. So that is why Dehradun is dry, Tamil Nadu is humid because it is closer to the ocean. And the last question, Kerala gets hit by monsoon rains during June, but during the same month, Dehradun is hot and dry. What would be the reason? The reason is the southwest monsoon winds which blow from the Arabian Sea towards Kerala hit the state of Kerala during June, and that is why Kerala has rain. But during the month of June, Dehradun, which is much more far away from the ocean, is getting so much heat and is becoming dry because of low winds which blow from the northern parts and western parts of India towards the central part of India, flowing through Dehradun and other states of central India and northern India. So these are two winds. One is a monsoon wind, one is a dry wind, and see how it totally affects the climate of the place. Okay, so I hope all of you were able to get the answers. So this is the last slide of the video, and these are some places all around the earth which you might have heard of, and these places have extreme temperatures. Some places are very hot, some are very cold, some are very dry, some are very humid, and you can start guessing what might be the reason. They'll show all the places which are in the falling under the category of extreme temperatures, and you can start guessing what might be the reason why this place has this kind of temperature. I hope you enjoyed the video and had a meaningful time of learning. See you in the next class.